Lab is to determine the hydrolysis of salt, and we have sodium carbonate here already in this glass, and we're going to add a small amount of water,
10 milliliters.
10 milliliters, with our cute little beaker, and get that into solution. And we have 8 other salts that we're putting into solution: sodium chloride, sodium bicarbonate, sodium oxalate, sodium sulfate, sodium chloride, potassium nitrate, and copper 2 nitrate, as well as calcium sulfate, which will be over here in a minute. It's Allie pouring water everywhere.
Okay.
Stay right there.
We have 9 salts in solution.
Alright. So, now we're going to use our glass stirring rod that I'm about to rinse off to determine, to get drops of our solutions and place them on litmus paper. First, we're going to take our ammonium chloride and put a small drop of this onto the end of our pH paper. The color of the pH paper appears to be neutral. One more salt to potassium chloride, which we are getting now. And we will determine the pH for us.
5 and 6.
It appears to be around 5.5. The pH of a solution is determined by the strength of the conjugate acid or base that the salt within the solution will produce. So something like sodium chloride, NaCl, will produce a very strong base as well as a very strong acid, which in turn will neutralize the solution. But something like sodium carbonate will produce something very basic because sodium hydroxide is a very strong base, whereas carbonic acid is very weak. So the solution becomes basic. The sodium's conjugate acid will be very weak, and the carbonate's conjugate base will be very strong. Exactly. Whereas if you had something like magnesium, well, I guess if you had magnesium chloride, your solution would become very acidic because hydrochloric acid is much stronger than magnesium oxide. So your conjugate acid would be stronger than your conjugate base. Yeah. All right.
Goodbye.
Remember to always clean up your lab station and not get water everywhere.